follow-up. So basically I'm continuing the Stanley Meyer slides, and that's because it got cut short. Ryan Cerny got kicked from the YouTube stream for some reason, and so I continued the stream and I uploaded it, and I saw an hour and a half upload, right? I streamed for another like 45 minutes or so by myself, and then on YouTube you'll see there's only like 49 minutes and 22 seconds that actually got uploaded, so that's kind of lame. That's my cat Hope over there. She's adorable. So yeah, current event. We're breaking all historical records for the rainfall in China. I wanted to go through some of my own personal notes here. So basically, this is out of my notebook, and it's just some thoughts from me and kind of putting some stuff down on a page. And capacitors are part of the impulse technology, right? So, sorry, I got stuff in my teeth. But yeah, you need a source to get started, and it can increase power out by a voltage multiplier if you wanted. And 0-point energy is defined as this, where H is the Planck's constant over 2 pi, so you can think of it, 2 pi r, where r is maybe like 1, for example, so it's like a unit circle. And W is the angular frequency of the oscillator, and everything's oscillating all the time. That's kind of the law. And yeah, fixed wave end versus open end. Fixed wave, you can kind of see they'll travel through each other and cancel and flow, and this they'll kind of build onto each other and flow through. And so this is like a wave with a fixed end is kind of like an altermagnetic one-wire feedback where you cancel the superposition, and over here where you have an open end you have a looped wire position where you're stacking the superposition. So that's kind of the difference between a one-wire system or a looped wire, and a looped wire can behave like a wave with a fixed end, but you have to configure it right. So impedance is kind of like your cause or your resistance. It's like hitting a wall, a difference in density. With every light reflection there's a partial, or with every refraction there's a partial reflection. And so when we consider light going through any material, we have to consider how it's doing that with each layer in the material. And resonance is kind of when your E in equals your E out. So you basically have a cyclotron, RF cyclotron, that when you turn it on and you turn it off, the peaks are equal to each other. And that's kind of the condition that builds that, which allows the electron to just keep coasting together. And when you overcouple it and you turn it off, you can get the turn off spike bigger than the turn on spike. And so if you can get a condition to where you are basically switching from under to overcoupled as you see fit, then you can really control cyclotron resonance and energy flow through the torsion field. And so I thought this was really interesting with the PEG cell battery charger. When I saw this, it really captivated me. I'd never seen anything like this. This was like right after I found Joel Agace, and I thought it was super important, so I wrote it all down, and I just started writing down my thoughts around it, like the limit of 1 over t as frequency goes to infinity, and as you increase, frequency, you're basically decreasing the current and increasing increasing the voltage, right? And so you can see the AC red is like the hot mixing, and then we basically are keeping the dipole ringing. We're taking the oscillation from the mains that the meter doesn't read, and we're utilizing it for power transmission into something usable. And Google will tell you displacement current doesn't do anything, but I'm here to tell you that it definitely does. You want to see my power bill? If you don't believe me, displacement current does real stuff. And I'm not even very good at it. So yeah, peg cell, 1.2 volts. I've experimentally verified that with Joel's work, and I output 5 milliamp range. And then this goes into Garrett Modell's work with electron tunneling, nickel to palladium. There's a delta V there. There's a difference in electron volts between different materials, and when we consider the Al2O3 structure, we get this chirality with the Bose-Einstein condensate of the electron, which makes a RF cyclotron condition, which essentially makes the K, M times P is K for those who are familiar with material science. We're going to get into that. But M is like extra electrons in a material being doped from that crystal lattice over on the periodic table. I guess I'm backwards here on the camera. And so type P is like holes. So that's why you hear old man talk about holes all the time. And so you can see there's 6 oxygen surrounded by 4 aluminum, and you get, 10, like summing to maybe like representing maybe a neon gas, and the aluminum gives you the oxygens, right? And you have this hexagonal structure on these planes which create a torsion field. And basically, as the ether is flowing, it's kind of like going over a wing with the Grebennikov study of the scarab beetle upper wing structure. It kind of has a similar microstructure in a macroscopic way, forces the flow conditions to help the beetle lift. And so the wing is actually acting like a diode, and it's utilizing back EMF like a one-wire circuit, in addition to this cyclotron resonant slingshot, I'll call it. It's like a charge slingshot. That's what water can do when you spin it the right way too. I've had a water cell discharged like that far with a purple thing of lightning in a tiny cup of water to my arm. It doesn't really hurt when it's a high frequency coherent condition. So the anyways, this is kind of going into induced EMF. Just gonna kind of scroll through here. You can pause whenever, but this is just some examples so you can start doing your own or whatever, like a solid state Moray generator, like basically like pickup coils for the noise around us. And the anomalous Hall effect is time-breaking symmetry, and you have a change in your B field with an altermagnetic field because the quadrature D field creates spin aggregation with the standing waves of the scalar wave, right? So spin and momentum become independent when exchange coupling takes place, and the key is decoupling of the spin space with the momentum space. So everything is coupled through the entanglement of light if the light is touching it, but if there's a quadrature nature, there's one region that's kind of separated from another region. So you can have a local net zero, but when you zoom into a certain area, you would have an asymmetry, and this asymmetry of these regions allows the dipole to keep ringing the dE/dt oscillation, as you go up with that, increases your displacement current density, and that makes the work done by the uncurled magnetic field able to be utilized when you couple it with a drift velocity to displace real charge. And so you have a one dipole and reversal spin polarized current that creates non-relativistic effects, which leads to all sorts of different sorts of things. And they tried to cover this out. This is elemental transmutation right here, just to be clear. And so you can see there's ferromagnet example, isotropic. You have up spin electron, down hole in Fermi space. All models are limited, right? So let's not get caught up in it. Superconductor, you have up electron, down electron. You have electron-phonon coupling, which has an unconventional D wave pushing a G wave, gravity wave. Input energy, Alexis Joule-Gays, for example, they have a trigger input source. They've shown that that is, as far as I'm aware, required. But once you get it going, it can keep going. That's cool. And so you have a change in sign, EMF, DC impulse. We'll see with the Don Smith capacitor method that there's a change in sign, a change in polarity, like the Mobius strip. When we look at the Perry-Weiss model, we see paramagnet is represented like this. Ferromagnet upspin space, Fe2 plus ion, quantum asymmetrical spin. If you want to get into that, which I can pull up in my books. And then, antiferromagnetic is kind of like, it cancels, but it's like this. But it's like all net canceling. And then your altermagnet is like, oh, well, now it's canceling, but it's structured along these diagonal lines. So you have these lines of symmetry like this. And if you were to rotate that, which all charge is rotating, you get these cones, these conical structures. Now we see with the alter spin polarization and the applied electrical bias how if you have a horizontal bias electrically, right, like what Ning Li was doing, then you see that the electrons aggregate. Now we're getting into Hall effect sensors and how those work. And what even John Bandini was doing with his rutiles and how he was so caught up in these rutiles. By the way, most of Earth's crust is made out of this material, and solar panels, transistors, all that stuff is made out of these materials. If you take any semiconductor and dope it, i.e. you just bond it to a pair of balls, i.e. diatomic oxygen, you get something that is a switch. And if you're connecting the dots between the RF cyclotron thing from earlier, then you're really gonna be like, oh, that's cool. Okay, so check this out. Your body has iron in its red blood cells, like a hematite pulse. And you can go from Fe2 plus to Fe3 plus. So you have Fe2O3, which is an alpha polymorph, which is octahedrally Fe3 plus ions. This is in the terahertz energy and picosecond time pulse. So you basically get these very fast hematite pulses. That's why iron switches flux really fast and really well, and why iron is like the last thing in the sun that can be bonded until you get a supernova. But that's besides the point. What's interesting is the ionic aspect of it and how it can basically go from ferromagnetic to antiferromagnetic, and like basically a quadrature D wave to a net canceling wave, like a semiconductor and a non-semiconductor, back and forth, back and forth, back and forth. And so basically what that does is the Fe2 plus state is like slingshot, and the Fe3 plus is like the altermagnet. And you can create this sort of penning trap effect. And a penning trap is anything that just traps charge. And so that's what the Merkaba generator is, which is a time crystal, which is the same structure of a quartz, right? That's what it's really doing, is it's oscillating a charge in a crystal lattice structure in an organized way, which keeps time. So to understand this more, look at Malcolm Bendel's work on the plasmoid unification theory, and he goes into the time crystal and the tunneling through the altermagnet and the spin-dependent conductivity, which is only in the D wave, the altermagnetic state. Okay, so waves continued. So you have note superconductor stuff, semiconductor stuff by Dr. Bratton, Nobel Prize winner. You can look him up in the AT&T archives on YouTube. Look up literally AT&T YouTube channel, go to their playlist, go to their archives playlist, scroll through there and look at some stuff. It's awesome. So, yeah, as you increase current, increase temperature, you get more radiation with these semiconductors, whereas like with these metals, you know, increase temperature, you decrease current, right? So this is like a normal resistor, and this is like a negative resistor, meaning that normally when you dump current into something, the movement of the charge heats it up. That heat, that thermal vibration, dissipates infrared, and it dissipates heat that you don't want in from the circuit. Now, the semiconductor, it's not doing that because it's a switch, and so it's gating the current in time, and so you get energy transmitted differently. Okay. So basically, we know that the negative goes to the positive more than the positive goes to the negative. We know that M equals P if K is linear, nothing special, but K is non-constant if you collapse a scalar wave through an NP junction, meaning that you have this germanium. Maybe right here you'd have argon, and maybe over here you'd have gallium, and the difference between that is a little galvanic cell, but you'd utilize Marcus theory maybe, and the distance of these molecules oscillating it with light, never breaking the bonds, but basically acting like a galvanic cell, a dry cell without breaking it. And it just keeps going, and it just keeps making light into matter through the Bethe-Hilter process, which is what a solar panel does. So don't tell me it breaks the second law of thermodynamics. Anyways, for all you haters out there that don't understand, look up cyclotron resonance. The mass of the electron goes down with the altermagnetism. And with this K constant, as you increase the frequency, shorten the distance between something, and increase the voltage, you increase the probability of the electron teleportation. And if you want to understand the Bethe-Hilter process more on a deeper level, maybe consider that neutrinos can make electron pairs by stacking sub-H vibrations. I don't know, that's just a theory, but yeah, square the circle here. We got a square of light, and the circle, the sphere, is a propagation of the light. So then, if I had this propagation of the light, right, out of this circle, and I represent it with a scalar bubble, maybe like 4 pi r squared HF, and electric potential, like maybe like 4/3 pi r cubed times K Q1 Q2 over R, then I find that like my radius becomes like negative 2 R HF divided by K Q1 Q2. So there's radius equaling radius. The radius cancels, so a number basically, you see that it's independent of radius. Kind of an interesting thing. Maybe spooky action at a distance, I don't know. Delta E critical, 16 pi times HF cubed divided by 3 times the sum of K Q1 sub Q2, or Q sub 1 times Q sub 2 divided by R, and that quantity is squared, right? So that's basically the same as saying pi over 3 times C, where C is your Coulomb, times V squared, where V is your voltage times R cubed, where R is your maybe your spark gap, or maybe the distance between the charges, or whatever. And so basically, what I think from my own notes is that the probability, we see a negative frequency factor. So we see phase conjugate waves forward and backwards in time. The probability of teleportation for the electron from my notebook, which is maybe not right, maybe it's a close approximation, equals E raised to the negative 1 over T times H over 2 times the square root of 2m divided by HF. So if K Q1 sub Q sub 1 times Q sub 2 over 2 equals HF, then as F increases, your probability increases. So basically what I'm saying is you increase your frequency, you increase your energy, you shorten that distance, the increased probability of it teleporting, and now we're starting to understand the protium and the positive and the negative, the cold and the light, the trinary state and the binary state, flowing, imploding, and exploding a little bit better maybe. So we see that what Tom Bearden is talking about, this positive and the negative, is this dipole. It's a waterfall. There's an ether waterfall flow right here all the time. All the time, already paid for in the mains of your walls. Now the Earth, I told you the crust is a solar panel. It's made out of 70% rutile material, silicon dioxide, in the crust. It is a giant solar panel, and the Earth is spinning, and there's a quadrant that is hitting the sun preferentially. So you have a quadrature flow, actually, because there's an inflow preferentially on one quadrant and outflow preferentially mostly on the opposite side diagonally. You see that? Okay. Now that we've established that scaling aspect in our mind, from a crystal lattice structure all the way up to the entire planet, we really start to understand what these devices are all about, what Nikola Tesla was doing, what Dr. Ning Li was doing, and we see that everything is fractal in nature. The quartz does it, the two-sided quartz. The mechanical stress creates electric charge displacement. Crystal, when vibrating, acts like an LC circuit. Except the crystal does it better than your LC circuit, every time. That's why, John Bandini loved collecting rocks and stuff. Yeah, just a little consideration. Every cylinder sphere oscillates in the presence of a fluid flowing past it, and that can be utilized to do work all the time. Whether it's a buoy, whether it's those little road markers on the side of the road, that could power like lights instead of your solar panels that are frying in China on those street lights creating fires. Solar panels are great, don't get me wrong. There's time and a place for them. You want to make resilient systems. I'm trying to show the people how a little bit better. So, yeah, I'm not going to get into the Joe cell, but check it out. Pulse DC with water. So the copper bowl, copper oxide outside, inside is this crystal alum with a magnesium. It basically acts like a diode and a battery all in one. You just wet it with the humidity. So here's your SG build with your little copper bowl ion gate valve. So, like I said, you can pause the page whenever. Here's your little light switch for a solar panel if you wanted. If light is on. So your SG mode is always going to output an H wave. This H wave can be produced wirelessly through the transistor. It doesn't have to be on or running. The switch on the input side of the source can be off. You just have to have the voltage going to that switch and so you can collapse the waterfall, right? That's all you need. This will grow crystal over time, and we're going to get into that with the rest of the slides of the scalar-Meyer chemistry because of our atmosphere and water. So it's not quite the same, but it's related. So crystals will oscillate with gravitational waves. That's what John Bandini said. He literally said, it's burning the water. He burned water too. Yes, John Bandini and Stanley Meyer both burned water. So a little bit about sidereal radiation, how they utilize that in the stock market to buy and sell and take control over time by making people feel anxious, just so you're aware. T.T. Brown, you know, the gravity wave radio, electrogravitic communication. It's all wrapped up into this right here. And then if you wanted like to create a gravitational isotope, like the element 115 stuff, like this is how you would do it. So you utilize this lofting material, which is basically ion implanted materials. That's all it is. Okay, so the Navy was onto this stuff, yada yada yada, vortex, implosion technology, longitudinal impulse. Radio is a telekinetic force using electrostatics. That's what it is because it's driven by scalar wave. If you don't think that's what it is, if you don't think RF penetrates, you're wrong. It absolutely does. Scalar waves go through the whole planet and is not stoppable. If you think I'm wrong, watch this video. Just go ahead. Pay attention a little bit more. Okay, so consider that, you know, what a penning trap is, what the planet is. Why did they get rid of all the mercury light buoys from all these mercury glows? Just oscillates and glows on its own. They don't want that. They don't want the mercury full bridge rectifiers used for the cars in early 1900s. No. So, anyways, I guess we're going to go into this next because this is getting a little bit long. So I'm going to pause this, upload this, and then we'll get into the slides.